Back in the day when standard library became part of C++ library, and vectors and strings and other elements of the library became available, I kept, because there are so many elements in the standard library, I kept forgetting what should I use at what time. So I put together a little bit of a tutorial for myself, and over time populated it with features. So I'm just going to show you this today. In the end of this, of our outline, I have this standard library containers, which is week 13, but it's a good time for us to look at this. There's this animated tutorial on the website, again under week 13. So I'd like to show you a few of the you know, elements out of that. So first, I need to basically download it someplace. Doesn't matter, I'll just download it wherever it downloads, and I will say yes, keep it, right, and then I will run it. Okay, so say yes, run, and this tutorial basically is a tutorial on standard library elements. So we can start with vector constructors demonstration today. For example, here's a little program which basically says, okay, here's your function f right down here, which takes no parameters and returns no elements, no value back. It's a void function. So here's your vector of integers, and the vector is named v1, and the vector keeps track of its last element. It keeps track of its size automatically. So essentially, when we say construct this thing, this line that constructs the vector gets constructed and visualizes itself in this field. Okay. Next thing that I do is I'm going to construct a vector v2, but this time it uses a parameter 5, which is the number of elements to populate it with to begin with. As you can see, because this is a vector of integers, it gets populated with 5 elements at the time of its construction, and the default value for an integer is 0. So that's why the vector gets populated with 5 integers, which are all 0. So clearly, I don't think you need much effort to basically look at this sample and say, can I write a code like this? Yes, you can. You can just start experimenting with the code like this whenever you want. You can also create vectors dynamically. This time I'm saying new vector if I wanted to create vector dynamically at runtime. This is just for the demonstration purposes. We don't need it. But look what this constructor takes. This constructor actually takes v2, this vector, as a parameter, so it's going to make a copy of it, right? So I have a pointer to vector, but you can see that this is exactly an exact copy of the vector 2, which I've created earlier on. On the next line, I say delete this pointer and say I no longer need it. So I created it only for the sake of demonstration, and so on the next line basically I say delete. So when I delete it, this thing goes away and is no longer part of what we do. Then I say populate vector 3 with 3 random values. And that's just, again, for the sake of demonstration. So the random value that happened to be in the range from 0 to 100 happened to be 52. Again, if I exit this program and re-enter it, if I rerun it, you'll see that every time I execute this code, it will be populated with a different number. So this tutorial really does execute the code in the background, right? So then I say v1 equals v3, which means that you can assign vectors from one to another very simply. So right now I'm trying to say v1 equals v3, and if I do that, the elements are obviously copied over, right? So now v1 gets populated with 3 elements, 52, which are integers. right? There are all kind of interesting versions of ways to assign things to a vector. Again, I just wanted to briefly show you that you can use this tutorial to essentially learn those very essential and simple pieces of C++ standard library. So if I wanted to assign V1 4 elements of 77, I can do it by doing this. If I wanted to assign from vector 1 vector 2 from vector 1 from the beginning to end of it, I can do that, and it just basically transfers the values over to from vector 1 to vector 2. As you can see now, both vectors are the same. I can resize a vector, and I'm resizing vector 2. So you decided that, oh, I have too many elements, I want to make my vector 2 in size, and you can just say resize. And if you resize it again and make it 3, the missing element is populated with 0. And if you want to resize it again and make it whatever, you can resize and populate missing elements with something like this. Okay, there are things that you can do with the vector, which what we did in our code. Element access, another example. Again, we have a function, and here's a vector of 5 elements. Again, vector of integers populated with 5 zeros to begin with. We have a loop which basically goes loops through the entire vector from 0 to the size of the vector and populates it with 10 plus the index, which makes it, 0 becomes 10, 1 becomes 11, and so forth. So we populate our vector with 10, 11, 12, 13, 14. Then we say that you can access the front element and the back element by simply saying vector front, vector back. Okay, so vector front equals 1 and vector back equals 1, right? So this shows you that now the front and the back have become 0, very easy. And then if you want to update your vector, you can use other functions built into the vector and essentially refer to individual elements. So here I said vector with whatever index is equals 555, and basically the idea is that vector really, if I try to show you what's going on internally, what vector does, and if you read the standard library documentation for vector, right, vector, and its full name, of course, is STD, Standard Library Namespace Vector. What it does internally, it's, of course, is an object very similar to our inStack. So what it does, it actually keeps track of dynamically allocated array of integers, and vector has a guarantee that the actual elements that it stores internally are adjacent to one another in memory, so that they really are stored in an array. Okay, and so if I do this, this is what this vector does, and of course vector keeps track of the size, of how big it is, and you can access. So if I say vector. Right, if I say vector of integers, for example, right, v, and then if I want to add an element to it, I need to say v dot push back, right, and when I say push back, I will specify the value 123, for example, to push as initial value, and if I do that, I can then say v index 0, because all array-like structures in C and C++ and Java as well are 0-based, then the indices of my elements inside the vector are 0, 1, 2, 3, and so forth. So I can basically say, V0 equals 4, 5, 6, and this will be updating this 0 element, right? So it's really designed to act almost like a built-in array, except that it manages its size. You can grow and shrink those things dynamically, and this tutorial demonstrates graphically what happens inside the container when you execute a code like that. Just be aware of these things. What else I wanted to mention with respect to this tutorial? Some stack operations. Okay, we can look at the so-called stack operations inside the stack, which is essentially this time I'm creating a vector of characters, right? So a vector of characters, and we say push back character A, B, C, push back individual characters. Then we say also ranging from D to G, populate with some more by pushing them back, so everything gets updated. So at this point I have A, B, C, D, E, F populated there. And if you say pop back, it will actually remove an element from the end, right? So over here we had character F at the end of our container. If you want to remove an element, you can do it by saying pop back, and it just pops the element from the container. Then in the loop I will say, as long as the size of the vector is not 0, pop back. So that just goes back and shrinks the entire container, pops everything from this container, and it results in the vector, which is now an empty vector again. It was populated, but then became an empty again. You can run wild with ideas what you can do with vectors, and it just really is a very nice way of organizing your data, and I will show you one more piece of it, which is list operations.